Hey, student, how are you? Welcome to our session on complex numbers and the imaginary number I. I is defined as the square root of -1, and mathematicians use this to solve the following issue. The square root of +9 is equal to plus or minus 3. +3 squared is +9, and -3 squared is a +9. -3 times a -3 is a positive number. So what is the square root of -9? What number squared equals a -9? Well, in comes the imaginary number I. We can rewrite the square root of -9 as -1 times 9. And now we can take the square root of -1 out from under the radical, and we get I. Square root of 9 is 3 or -3. So the square root of -9 is 3i or -3i. And now we can check this. 3i squared is equal to 3 squared times I squared. And I squared is -1. So 3 squared is 9 times -1, and we do get -9. A very similar situation for -3i. Let's take a look at evaluating negative square roots. We can evaluate the square root of -25. We're going to get 5i or -5i. We always get both roots. Square root of -49, 7i or -7i. And the square root of -1/81. That's going to be 1/9 I or -1/9 I. You can take the square root of the top and the square root of a fraction, square root of the bottom separately. Square root of the top, square root of the bottom separately. Let's take a look at square root of -24. We could rewrite the square root of -24 as -1 times 4 times 6. And I chose 4 because now we can take the square root of 4 out from under the radical. We get 2. Square root of -1, we have I. And then the square root of 6 stays under the radical. And of course, we will get both roots. So we will also get -2i square root of 6. And the square root of -128, we can rewrite as the square root of -1 times 64 times 2. And I chose 64 because that is a perfect square. We can take the square root of 64 out from under the radical. Square root of -1 is I, and we'll leave the square root of 2 under the radical. And of course, we get both roots, so we also get -8i square root of 2. Moving on. Let's take a look at the complex number z. The complex number z has two parts. We have A, the real number part, and then B, the imaginary number part. And we can graph complex numbers on the complex plane. The real axis goes left and right. The imaginary axis goes up and down. Let's graph the complex number z sub 1. 3 is the real number part, so we will go to the right 3, and then up 5 on the imaginary axis. And this is z sub 1. Number 2, z sub 2. We'll go -2 to the left on the real number axis, and then down 3i negative imaginary axis. And that is z sub 2. Let's take a look at adding and subtracting complex numbers. And we'll add or subtract like terms. 2 plus -11 is -9. And then 4i plus 3i is 7i. Number B, 7 minus 8, we get -1. 3i minus 1i, we get plus 2i. C. C, we are actually adding conjugates. So interesting result. 5 plus 5, we get 10. And then 12i plus negative 12i, we get 0i. So we are just left with the real number 10. And D, 6 minus 6 is 0, and 4i minus nothing is just 4i. So we're left with the imaginary number 4i. Next, after adding and subtracting, we will multiply complex numbers. And I squared is equal to negative 1 is going to be very useful. Letter A. We'll distribute 2i into the parentheses, multiplying. And we get 16i plus 18i squared. And then I squared is negative 1. So we get 16i minus 18. And most mathematicians will rewrite this in standard form, negative 18 plus 16i, making sure the real number part is on the left. Number B, we will FOIL. 3 times 2, 3 times 4i, 5i times 2, 5i times 4i. FOIL. 3 times 2, we get 6. 3 times 4i plus 12i. 5i times 2 plus 10i. 5i times 4i plus 20i squared. And then we can add 12i plus 10i. We get 22i. And then I squared is negative 1. And we get minus 20. And then 6 minus 20 is negative 14 plus 22i. Letter C. We've got conjugates again, which we'll talk more about. And interesting to note what happens when you multiply conjugates. So once again, we'll FOIL 2 times 2, 2 times negative 7i, 7i times 2, 7i times negative 7i. 2 times 2 is 4. 2 times negative 7i minus 14i. 7i times 2 plus 14i. And then 7i times negative 7i minus 49i squared. Notice negative 14i plus 14i cancels out. And I squared is negative 1. So we get 4 plus 49, which is 53. Moving on, let's take a look at the powers of I, now that we know how to multiply. And taking a look, I to the 0 power is 1. Anything to the 0 power is 1. I to the first power is just I. I squared is negative 1. I to the third is negative I. And then we repeat. I to the fourth is 1, going back to I to the 0. I to the fifth power would be I. I to the sixth power would be negative 1, so forth and so on. So let's take a look at evaluating I to the 40th power. We're going to divide the exponent by 4, and we get 10 remainder 0. Since we got remainder 0, I to the 40th power will be equal to 1. 18, I to the 18th power. We'll divide the exponent 18 by 4, and we get 4 remainder 2. Since we got a remainder of 2, I to the 18th power will be equal to I squared, which is negative 1. I to the 81st power. 81 divided by 4 is 20 remainder 1. Since we got remainder 1, will be equal to I. 23 divided by 4, we get 5 remainder 3. So I to the 23rd power is equal to I to the third power, which is equal to negative I. Next, factoring a sum of squares. So factoring x squared plus 49, we have two perfect squares, and we are adding. we will get the factors x plus 7i, x minus 7i. And we can FOIL and check this. X times x is x squared, minus 7xi plus 7xi, and then minus 49 times I squared. The middle cancels out, minus 7xi plus 7xi, and then I squared is -1, so we get x squared plus 49. All right, let's factor a sum of squares. X squared plus 25, we get x plus 5i, x minus 5i. And x squared plus 1, we get x plus I, x minus I. And last but not least, we'll take a look at dividing complex numbers using conjugates. So we've heard conjugates throughout this video. Here they are. And they are very useful for dividing complex numbers. To divide a complex number, we're going to multiply by the conjugate. So in the denominator, we've got 3 plus 4i. The conjugate will be 3 minus 4i. 3 minus 4i, multiplying top and bottom by the conjugate. And then we will multiply the top. I'll leave that undistributed. The bottom, however, I will FOIL. So 3 plus 4i, let's write this out. 3 plus 4i times 3 minus 4i. And then we'll go ahead and FOIL the bottom. Times 3 minus 4i. And on the bottom, 3 times 3 is 9. 3 times -4i minus 12i, and then plus 12i, and then minus 16 times I squared. -12i plus 12i cancels out. I squared is -1. -16 times -1 is plus 16, and 9 plus 16 is 25. And then the 5 and the 25 we can reduce. Yeah, we're left with 5 in the denominator. And then a lot of mathematicians or textbooks will ask you to separate it so that you have a plus bi. So we can do 3 over 5, 3/5, minus 4/5, 4i, 4/5 I. So 3/5 minus 4i/5, or 4/5 I. And the last one here, we'll multiply by the conjugate. We see in the denominator, we have 2 plus 3i. So the conjugate will be 2 minus 3i. 2 minus 3i. And then we will actually FOIL the top here, 1 plus 4i times 2 minus 3i. And we'll FOIL the bottom as well, 2 minus 3i. Okay, we'll go ahead and multiply those out. And let's see, we get 1 times 2, which is 1. 1 times minus 3i, and then plus 8i, and then minus 12i squared. And in the bottom, we get 4 minus 6i plus 6i minus 9 times I squared. And I'm going to go ahead and simplify the bottom. -6i plus 6i cancels out. I squared is -1. Negative times a negative is plus 9. 4 plus 9 is 13. So we're left with 13 in the denominator. And then in the numerator, we'll simplify this. -3i plus 8i, we get 5i. -12 times -1, we get plus 12. And 1 plus 12, we get 13. So 13 plus 5i, and then we'll separate it. 13 over 13 plus 5i over 13. 5i over 13. And 13 over 13 is just 1. So we get 1 plus 5i over 13. And that concludes our session on complex numbers and the imaginary number I. Thanks so much for joining this session, and I'll see you next time.